We now know that if you are in emergency mode, you close via the disconnector switch and the breaker. In test mode, go ahead and close the breaker immediately. If you are in local or remote mode, opening and closing is done through the BCDU, the Bay Control and Protection Unit, and this is done via an output contact. In it, your relay goes down to it, and it is either in the test position or the service position. The service path takes a bit longer. Look, engineer, if you are closing a breaker in the service position to close a breaker in the service position, engineer initially. In the switchgear, for the switchgear, those who attended the GIS will have heard a bit more here. In the switchgear, all protections must be reset. What does this mean, engineer? You have engineer. A fault occurred on the circuit breaker, so the circuit breaker receives a trip command and disconnects. The breaker has tripped completely, so you need to come and see what the fault is, fix it, and then perform a reset. So, what does it mean to perform a reset here, engineer? What happens next? I will draw a very simple diagram for you, or I might use... The discussion was a bit old. All right. What is this? It's not forgotten, the BCU. The BCU is a device that takes the current reading from my feeder and takes the voltage reading from my feeder. All right. Based on that, it analyzes the voltage and current readings. And if you have a fault, it starts to close. What does it close? It closes or opens a general contact. All right? Nice. When this output contact closes, you have it connected to a positive, and its other terminal is taken here to a trip relay, and its other terminal is a trip relay negative. Now, this trip relay, engineers, is one of two things. Either something called 94 or something called 96. First, what are these numbers? They are called ANSI codes, all right? I hope someone can remind me tomorrow morning, God willing. Just send me a message on WhatsApp saying, engineer, send me the ANSI codes. They are 2 pages. They contain all the information and all these numbers. The 94 means self-reset trip relay, and the 86 means lockout relay or latch relay. What does self-reset trip relay mean, engineers? It's like an auxiliary relay coil with a set of contacts, normally open and normally closed, all right? And the 86 itself is a coil with contacts, normally open and normally closed. But the 94 tells you that as soon as the protection relay operates, meaning it detects a fault, it closes its contact here like this, it closes this contact. So the positive starts passing through here, reaching the coil of the 94, and the negative is connected, so it will operate. Then I take a contact from its contacts, which is a normally open contact, to perform the disconnection of the circuit breaker in the other circuit that we will look at together. All right, so as soon as the breakers disconnect, the current and the quality are gone because the fault has been isolated. The circuit breaker has disconnected the current from the fault and the quality from the fault. So the protection relay no longer sees a fault. What does it do? It comes back here and opens the circuit. And as soon as it opens, it returns. The 94 gets reset. So the 94 is isolated with quality. As you find it gets reset. What does it mean for the 94 to get reset? It means it returns to its normal state again, because the output contact from the relay opened. So the supply is removed from it and it gets de-energized once more. That's good. But the 86 engineers is something called it's called a latch relay. What does a latch relay mean? It means I activate the coil, and when this coil is activated, there's a magnet inside. I can show it to you, there's a magnet. The idea is that once it activates, this magnet holds the position, and it doesn't change. It doesn't change its position, even if the power is cut off, and the contact is disconnected. So it's not supplying voltage to the 86 coil. But once this coil is activated and changes the contact positions, there's a magnet that holds these contacts in their current positions and it won't change them. So how does it change? Either by a hand reset, where you manually come and reset it. There is a button on its face that you press mechanically to reset it, meaning you move the contact away from this magnet. Or by an electrical reset, which means you have 2 coils. These 2 coils have something like a balance between them. So when one is activated, it tilts the balance like this. So it keeps holding the balance in this position. To reset it, you need to apply a current to this coil to create a repelling force and reverse the position again. This is what we call an electrical reset. Now, what is the purpose of the 86? The purpose of the 86, which I have opened here in the drawing with you, is that when there is a fault in my feeder, as a basis for the initial feed, as a basis for the initial feed, as a basis for the initial feed, as a basis for the initial feed. And when I disconnected the electrical circuit, it's preferable here to take from it. In the closing circuit of the breaker contact, its position is normally closed. Okay, normally closed relative to what? We must return to the normal state. Any auxiliary relay, any trip relay, any lockout relay, any contactor drawn in your official diagram is depicted in the state of being de-energized. Without power, not energized. Good? It's not energized, it's not something. Anything drawn out of PUDL in a state, that means it's not things. Is that clear? So its contacts are such that when it operates, it opens this contact. So how is it reset? You must come and reset it manually. So this depends on the maintenance team. They will come to correct the existing error, check the cable, see whatever it is, and after fixing it, they will reset it manually, allowing you to reclose the electrical circuit. What happens if it was reset? Anyone might mistakenly think the fault is gone and close the breaker, which could affect the maintenance person. He might come and not realize that he hasn't finished his work, or someone else might think his colleague has finished the job. So why is it closed? No, there must be something here to prevent you. You must do what? Reset it. Or the person sitting at the SCADA might press close, thinking the fault is gone, and he presses close. No, even if he presses close and the contact is closed, he will find this path open. Okay, great. So what are these things for? Of course, it's not your task right now, the protection. But you need to understand this as a capacitor. I'm talking here about a capacitor bank feeder. As we agreed, this capacitor bank feeder is not forgotten. It has on it protections for the capacitor bank, protections for the bus bar, protections for the breaker failure protection, 4 protections: main protection 1, main protection 2, bus bar protection, breaker failure protection. These are the 4 things that start, they are the protection or the ones that disconnect the electrical circuit of the capacitor bank feeder. Whether it's main protection 1, it includes overcurrent, undervoltage, neutral overvoltage, and several other things. Regardless of the type of protections, whether it's main protection 1 or main protection 2, and you have busbar protection 1, if there's a fault on the bus bar, it disconnects the capacitor bank. And in the case of breaker failure, when any other cell has it, or rather when my cell has a breaker failure, I isolate the bus bar. At the same time, I prevent the reclosing of my other breaker until I fix my fault. Even when I fix the fault, what fault am I following? All right, so here you find a contact from 86C2 and 86C2. Are 2 lockout relays from protection 1 and protection 2. And here you have 86B, which is the bus bar protection. Additionally, you have 86CBF, B, from the breaker failure A protection. These are the 4 things to pay attention to. The other 2 things, I will tell you about them now, and we will come back to them again. When we explain the interlocking circuit, what are these 2, Engineer Rashad? They are T1 and K3. Look, engineer, this is a capacitor bank feeder, right? So follow along with me. If I close an electrical breaker, I will connect the capacitor bank. Let's connect the capacitor bank and let's take a look together.